Okay, pre-calculus 10, let's get after it. We are looking at my favorite and most pertinent video of your high school career, factoring basic quadratics. So what does that mean? A basic quadratic is of this form right here, x squared plus bx plus c. Now, a quadratic is a degree 2 polynomial. So from now on, I'm going to call them quadratics, okay? And I want you to look closely at how this comes about, right? Now we've seen some trinomials and we've factored some and we've done some multiplication with them, but we are going to factor what I call basic quadratics. There's no number in front of the x squared, okay? Now, look at this. If you have a binomial x plus a and a binomial x plus b, and I'm using generic terms here because let's keep it generic. When you FOIL this, okay, x times x always gives you x squared. And then you do x times b, or bx, right? Same thing. So that's your outside. And then a times x, which is your inside. And then a times b, right? Now, if you just look at our inside terms that we grouped together, right? If you factor out the x, you end up with b plus a. So what that means is your middle term is b plus a, and your outside term is b times a. Okay? So let's just for a second, and we're going to look at this on the next slide, look at if we had two binomials. If we FOILed this, okay, we would get x squared and then plus 3x plus 2x plus 6. And if you simplify that like we did on the other videos, we end up with this. So what do you get? You get the two terms in the middle, right? They multiply to 6 and they add to 5. And it's the same numbers. So that is the pattern. That's going to come in handy. So here we go. How do you factor this? Remember that we are reverse foiling this. Okay, this is reverse FOIL. And if you have nothing in front of the x squared, you know that your f is always going to be x, right? Because if we went x times x, we would get x squared. So you've already half factored this thing. All you need to do is figure out what goes here, and what goes here. And remember that we just talked about it. You're looking for two numbers, okay? We're looking for two numbers, a and b, from our example, right? Because we had a plus b times x, and then we had plus ab. That was the back of our abstract form, okay? So we're looking for two numbers that add, in this case, to positive 7 and multiply to positive 12. So we're looking for factors of 12. So when you're first starting this and you're not automatic, list the factors of 12. What are they? And be careful because we need to list them with their sign. Okay? What are the factors of 12? Well, 1, positive 12. Positive 2, positive 6. Positive 3, positive 4. But also negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. Remember, because you're looking for two numbers that multiply to 12. That's going to give you this back number, right? And let me just remember a times x, or x plus a times x plus b, gives you that. So of all that list of factors, that's going to satisfy the plus 12. And what we're looking for is those exact same two numbers have to add to 7. So all we're looking for is what is that? Well, those two add to 13. So no. Those two add to 8. No. Those two add to negative 13. No. Those two add to negative 8. No. Those two add to negative 7. Close, but no. Only those two numbers add to positive 7. So we just plunk them in with their sign attached, plus 3 plus 4. And just like that, you have factored this quadratic. You have reverse foiled. And if you were to FOIL it to check, x times x is x squared. X times 4 is 4x. X times 3 is 3x. You add those together, you get 7x. And then 3 times 4 is 12. So boom, you're looking for two numbers that multiply to this one and add to this one. That's how you factor these things. So once you start going, it's going to become automatic. It's going to become pretty simple. So, factor me. Careful, is this in descending order? Put it in descending order first. So we'd rearrange to x squared minus 6x plus 8. So right away, you can half factor this thing. I know x, I know x. So now what are we looking for? We're looking for two numbers that multiply to that. Okay, we're looking for a times b equals 8. And we're looking for an a plus b that equals negative 6. So again, what are the factors of 8? Well, 1 and 8, those are positive, 2 and 4. But then also negative 1, negative 8, negative 2, negative 4. So which of those pairs adds to negative 6? No, 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 yeah. So x minus 2, x minus 4. In the notes, you'll see at the end there's a summary of patterns with respect to negative number in your middle term and a positive number in your outer term and vice versa. It's in your notes. It's not included in the video. I'm just focusing on the factoring here. So let's do another. Now, if you're pumping the brakes, it's for good reason. I just told you that there's never a number in front of the x squared, and all of a sudden we have one. So what do? Well, we can always do two-stage factoring. First, we're looking for the greatest common factor. Can you factor this 5 out of all of these terms? And if you can, do it. If you can't, that's what the next video is for. So in this case, we can factor out a 5. And what are we left with? X squared plus 7x plus 12. So that's nice. Now I don't have anything in front of my x squared. And now all of a sudden, what am I looking for? I'm looking for two numbers. A times b is 12 and a plus b is 7. So I've already done this before. It's 3 and 4. So now the 5 stays as a factor, but then I can factor my inside as x plus 3, x plus 4. And that is the fully factored form. You need to include the 5, otherwise it's not the fully factored form of that thing. So factor out your GCF first, and then do your reverse FOIL factoring. Now you might look at this one and go, well, there's not really anything in front of that x squared, but there is. It's a negative. And what is that negative? That negative is a negative 1, right? So we're going to factor out a negative 1 from everything. So we're going to reverse water bomb a negative 1. What it's going to do is change all my signs. And now I'm looking for an a times b that is equal to negative 6 and an a plus b that is equal to negative 5. Now I want you to consider this for a second. I need two numbers that multiply to negative 6, which means one has to be positive and one has to be negative. So that leaves me with negative 1 and positive 6, negative 2 and positive 3, or 1 and negative 6, and 2 and negative 3. And then which one of those add to negative 5? Well, no and no. Yes. So here I just want to show you a quick subtle difference. Imagine we had this. In this case, we'd have two numbers that multiply to negative 6 and then to positive 5. So we'd go with that one. So one subtle sign change will change your factors completely. But there's another thing to consider. What if you had a plus 6 on the back and a negative 5 in the middle? So again, one sign change. Well, now my numbers need to multiply to positive 6. So I would have 1 and 6 and 2 and 3 and negative 1, negative 6 and negative 2, negative 3. But they need to add to a negative number. So I can't even consider my positive values. So that's why knowing the signs, There's a little bit of strategy that can go into knowing your factors as you get better at this, because in this case, it's got to be those ones. Sometimes people will pick those in the scenario we have just as a mistake because they're not fully considering the multiplication. So just be careful. Don't let your ego get in the way. List the factors if you have to, please, as you first start so you get comfortable. So we just identified that this factors out to x minus 6, x plus 1. Now, you might be asking yourself right now, why are we doing this? What's the point? The point is when we get into grade 11, we set these things equal to y, or to f of x, and we start solving for when y or f of x is 0, because that will give us our x-intercepts of curved graphs, which is where we're going. Eventually, we will look at something like this, and the foiling gives us those 2 points. So it's going to come in handy. That's why we're doing it. We're practicing it kind of out of context in this grade, and then we throw it into context in grade 11. So here's another one. Again, GCF first in this case. So I'm going to factor out a -3 from everything, but you'll also notice x values, x values, x values. So I'm going to factor out a -3x squared, and sure enough, I'm left with x squared plus 6x plus 9. So now I'm looking for two numbers that multiply to 9 and add to 6. Well, that gives me 1 and 9, or 3 and 3. And since this is positive, these have to be positive. The negatives won't work. So there's my answer. And this is a special case, but we'll talk about this in a couple slides. We get x plus 3, x plus 3, which is -3x squared times x plus 3 all squared, if you want to be super precise. So what I just did there was what was called a perfect square trinomial, and I'll show you two more here. So this is when we had multiplication. Remember I showed you a special case where we had the same number repeating, right, which is a perfect square trinomial. And I showed you an interesting thing about that. When you foiled that, you ended up with a middle term that was, well, let's just work backwards and you'll find out. So I'm looking for two numbers that multiply to this, add to this. So 1 and 16, 2 and 8, 4 and 4. And again, since this is positive, these all have to be positive. The negative counterparts won't work because I'm adding. So, oh, and because this is positive. So the only one that works in this case is this one, 4 and 4. And you'll notice that what you get is you get two identical factors. You end up with that perfect square scenario. And notice the difference between 8 and 16 from this question here, from right here, right? The square root of 16 is 4. And the reason why that makes make an issue of that is because when we're doing our FOIL, our last is 4 times 4, so 4 squared. And 8 was 2 times 4, because when we FOIL it out, we would get 4x plus 4x. So if you notice in your trinomial, if you have a middle term that is 2 times the square root of the back term, 4, you have a perfect square trinomial. What differs then is the sign. So if you look at the one on the right, we have it again, except this time we're going to have x minus 4 and x minus 4. You can never have a perfect square trinomial if this is a negative, because you couldn't multiply the same number by itself and end up with a negative value. So again, there's a strategy to identification for you. But in this case, we'd be looking for two numbers that multiply to 16 and add to -8. So we would include -4, -4, -1, -16. And that's how you find your -4 and your -4, which again is x minus 4 all squared. Now, I understand that I'm going through this video in 10-15 minutes, and this is not easy to grasp. So watch it again while trying the questions, while reading the notes. You want to tie everything together. This world of instant gratification is great. It'd be nice if you could watch this 15-minute video and become a professional, but it might take a few times through. So please consider it, because there are a lot of different scenarios here. Now remember, these we saw as well, and these are special too, because we're now looking for two numbers that multiply to -4, but there's no middle term, right? Which means we have 0x. So you're looking for two numbers that add to 0. Well, that's easy. It's just the same number with opposite signs. So you would end up with x minus 2, x plus 2. Now, what do we call this? We call this a difference of squares. And the reason why we call it a difference of squares is because that term is a perfect square. That term is a perfect square. And that is subtraction, which means difference, right? If addition was sum, subtraction is difference. It is literally the difference of two perfect squares. Whenever you have that scenario, it simplifies to the square root of each one and then plus or minus. So here we have a perfect square, so we're going to have x plus, and we're going to have x minus, and then what's the square root of that? 6. Done. Difference of squares are so easy, but they get missed often. But if you can't remember that, you're still looking for two numbers that multiply to this, except in this case, it's two numbers that add to 0. So you can still work it out intuitively, but get comfortable with, is that a perfect square? Is that a perfect square? I have no middle term. That should be boom, boom, ding, 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 alarm bell, right? No middle term. It's got to be a difference of squares if that's subtraction. So that's another one of our special situations. So here's two more that you might think, well, they look kind of like a difference of squares, but they are. Is this a perfect square? Yup. Is this a perfect square? Yup. So what do you get? You would get x plus x minus, and then square root of that is y. So now here, it's maybe kind of hidden, but it's not. Look at the individual factors of each term, right? This thing, is that whole thing a perfect square? Which means, is that a perfect square? Yes. And is that a perfect square? Yes. So 2x, and then it's subtraction, so plus, minus, and then is that a perfect square? 5. So easy enough to identify if you know what you're looking for. So just make sure you get comfortable knowing what you're looking for. We have difference of squares, we have perfect square trinomials, and then we have your basic guys. But it's always looking at two numbers that multiply to your last term and add to your middle term. And the front term is always going to be your x and your x. And that's because all of our quadratics in this case start with an x squared with nothing in front that can't be factored out. The next video focuses on when you have a number in front of that you can't factor out. So watch this one multiple times, get incredibly comfortable factoring. I mean this seriously. You need to be able to factor these basic quadratics in 30 seconds maximum. They need to become easy. I always say, you know you're comfortable with it when you laugh at how easy the question is. If I give you a question that I expect to take you time and you laugh at how easy it is, you're ready. That's the goal. That's where you want to get to. Okay? Enjoy. Keep on working. Let's move forward.